on. So for the solution, you have a document that tells you what and how to do, and then you have a rubric so you can check how your submission fares against the score sheet. So when you use the rubric, that actually helps you do higher, score higher on your first submission. So what you're doing is you're using the same score sheet I use. Did the student capture detail showing the brand, model, hardware version, and MAC identity of the network interface used on his or her device to the internet? I'm talking about the service router. And it's either a yes or no answer. Everybody see that?
Yeah.
Okay, now there's 2 points for that, which means the brand is part of that, the model is part of that, the hardware version is part of that, and the MAC identity. You could say that a half a point each for those 4 items. So what happens if you speed bump this and only give me the brand and model? You're in a hurry and you grab the thing, you take a picture of it and you submit it. Well, I have the brand and I have the model, but I don't have the hardware version on the bottom with the label, and it doesn't show the MAC identity. Well, if you'd get a good picture of that too, I'd have everything. But I would score 1 point because 2 of the items are missing if you're in a hurry. That's how I do this, right? Now, any questions about what I've just shared with you on the solution?
No, sir.
Okay. Well, we did state in class that if you're in the dorms, you can do this at home, at a friend's house, with a relative, if they have a service router, or if they have a Wi-Fi router in their home. And it's a good thing for you to do it with them because you'll be taking stock on how their network is configured, and there are simple opportunities to greatly enhance the performance of their network later on. So I want you to notice this. It says extension of the submission deadline will not be possible for this submission, right? Please adjust your schedule and priorities accordingly. Why am I saying that? You need to do this hands-on before you take the assessment. You will do much better in this assessment if you do the hands-on before you attempt the assessment. And when does the assessment due? 11 a.m. Monday. Well, can we push that back? Not if we want to get our grades in, our credit scored for submissions, and we get a sense of average for the midterms, right? Will there be a midterm exam next week? No, there will not be a midterm exam. I will post a midterm exam a few days later after we complete a shorter review. Module 3, the 2 longest modules by far are 1 and 2. Module 3 is shorter. It covers less material and we can be done with it sooner. So in a week's time, we're ready to take the assessment for module 3. At that time, once people have had a chance to reconcile and retake module 3, we'll post the midterm. So we're only a few days behind in terms of the midterm exam. But it's done at your own pace anyway. It's not a final exam, so it's not as long. You can complete it in 90 minutes instead of 2 hours. And it includes all of the material from modules 1 through 3. Okay? Any questions about our expectations for module 2? Any questions?
No, sir.
Okay. All right. So let's launch into module 3. Module 3 is about layer 3. I want you to notice the progression. Here's the origins and essentials, and we focus a lot on the physical world. But then we talk about physical and layer 2, data link layer and physical together in module 2. Then layer 3 in module 3, then layer 4 in module 4, then layer 5 in module 5. That's the pattern. Okay, that's what the L means. Layer 3, layer 4, layer 5, layer 2. I could write that L2, but I wrote it out here. Okay, so there are some chapters. You do some sections in the textbook from sections 3.1 through 3.12 in chapter 3, but then you fast forward to chapters 20 and you blitz 20 through 26. Now you're scanning these sections. It's a lot of material, so with your textbook, You basically want to spend some time looking through this stuff, and that'll help what's in the study guide make a whole lot more sense. Any questions before we start our content review for module 3?
Nope.
All righty then. Good day. Good day, Desi. How are you? Can you hear me, Desi? How's your audio? Maybe Desi's in a place where Desi cannot respond. That's all right. Just can you put in the chat? Oh, okay. Desi did. Thank you, Desi. He says, yeah, the internet sucks, so chatting. Appreciate it. Very good. Yeah, that's always a good tool. Or you can raise your hand too. There's a little thingy on your Zoom screen where you can raise your hand if you're trying to get my attention. Or unmute your mic and say, hey, Kentop, stop talking. All right, so here we go. This is the Module 3 study guide. It's in its 3rd revision. We are revisiting our network classes and the components of an IPv4 address, including essentials for communication. What do you need to communicate on a network as far as the address is concerned? Then we're going to explore common challenges and enhancements to improve routable networks. So this is where everybody needs to lean in. If you wanted a value added from this course, this is where we're going to learn some principles that will help you get better performance out of your networks. We'll present 3 innovations that are used to resolve the shortage of public IP addresses. And then we'll present how it is that CIDR, this is pronounced CIDR, C-I-D-R, that stands for Classless Internet Domain Routing, right? CIDR, it's an adaptation of how you use the subnet mask, and it has to do with sliding up and down the scale 1 increment at a time. We touched on that a little bit in our first module. When you do it intentionally, you can greatly conserve the number of public IP addresses that are used and avoid waste. You can also protect your network by carving down the landscape so hackers have less room to maneuver. Everyone, this is Friday. I'm trying to be a little candid here, and I want to keep this light. But at this particular moment, I just want to ask you a simple question. Do you think configuring any network so that there's all this room to maneuver and manipulate makes sense if you're trying to keep the hackers out?
No.
Did you know that when the manufacturers give you the equipment, people plug it in and use it? The manufacturers just want it to work. They don't want a bunch of people calling them saying, I just bought this thing and it doesn't work. Well, they don't know how many devices you have, so they turn up all the dials. This is bad. This is a problem. This
Well,
is
when
yes.
Cisco, they give you the product, and then if you're like in an IT department, you would have to configure the switch on yourself. Because
Yes.
you have to know the config, terminal, show run, all those commands.
Yes.
So that you can be able to configure the switch.
Yes, in a Cisco environment, in a commercial setting for a business or an organization, the expectation is, hey, somebody that's network qualified would know how to do this. There are many residential networks where people just set up stuff out of the box. And it would shock you to know the number of places where they buy Cisco, but they just turn it on and they accept the defaults. And that's very, very bad. But I appreciate the sensibility of your remark. It's a good point. When you use certain levels or certain types of network equipment, the expectation is, oh, you've had training or education in networking, not unlike the training you're getting right now. Okay, so we want to revisit this. You already know that when you have a network address and you have a subnet mask, you can determine which portion of that network address corresponds to the neighborhood or the network identity, the network ID. The remaining portion of the network address is the client address or street address of the house or building, in this case, the device or the system that's connected to the network. If we were to use the analogy of roadways and homes and, business buildings and such, right? As an analogy for a network, you'd have a zip code and then you'd have a street address. That's the client address. So hackers can manipulate these differences. They can adjust that subnet mask so they can see things they're not supposed to see. If they shorten the subnet mask, typically they can see a lot more of the landscape. If you're segmenting the networks or breaking them down into smaller chunks, it's a lot more difficult for hackers to do that. Now, this is the other part that most people don't know. If that's all you have, you can talk on the same local area network. If you don't have a gateway address configured and listed as a part of the IP stack configuration, when we say stack, we mean the IP protocol. You're configuring the gateway, the DNS server, all these different, the DHCP server, all these different things. If they're not configured in the broadcast domain on the second layer and with the networking, basically, if you don't have a proper IP address for the gateway, you can still communicate, you can still get around on the local area network, but you just can't get out of the local area network. It's the gateway device that you have to get out to the internet. And if you don't have that, or if it's improperly configured, or if a hacker sets up their own address and then resets the DHCP so everybody pushes their traffic in that direction, the hacker can intercept everybody's local network traffic and then pass it on out to the internet as if they were the gateway. That's called a man-in-the-middle attack. It's a very effective, very nasty, very evil way of getting everybody's information. We take a lot of things for granted, and if a gifted hacker is in the neighborhood, a gifted hacker can compromise the DHCP services, and that's one of those Achilles heels that are occasionally compromised. Not many hackers are thinking on that level, though. DHCP is intended to automatically configure devices and systems so that there's confidence in what address is being taken. Remember that if an IP network address is duplicated in the same local area network, everything just collapses, right? The whole building, it's a big crash, everything collapses, right? So to talk outside the LAN, the device needs a gateway and an actual router that's sitting on the same address for that setting. Now, that's why I made the remarks I did. If you have a router that's sitting on the network and it's not properly configured, and the devices are pointing to the gateway address that's different, it's not going to work. If they do have the right configuration, but the router is not set up properly, then it won't work either. It's one of two possibilities, right? So when you're having internet problems, the other thing is domain names. So there's a fifth piece here. Once communicating with other devices outside the LAN, inside and outside the LAN, a DNS server changes named resources on the network. We use that term intentionally, named resources on the local network. That's a function of the domain naming system server. So the DNS server is working that, it provides the IP address for the name. When you type in Google or Amazon, it's a DNS server that gives you the IP address as they change, because they change constantly for big companies. And so in order to use domain names to communicate with networked resources, named resources, that requires DNS. A DNS server address must also be set up in the IP protocol stack And that allows the application layers that use names in layer 5 or 7 for the industry model or the OSI model. This is what allows the applications to work with names when you're emailing somebody by name. If you don't have DNS, yeah, the email name doesn't work. It'll say, yeah, I don't think this name exists. You can get false errors for your email delivery or your web browsing, and it'll say that something doesn't exist or it can't reach it, right? So, any questions so far about DNS? Yes, it's that critical. Now, an actual DNS server must be operating at the given address to provide DNS entries. But usually what happens is that in your router says, I'm the DNS address. And when your router gets a DNS request, it refers that or passes it, it forwards it to another actual DNS server. So that's one reason why a Raspberry Pi configured as a Pi hole is such a security and performance enhancement. If you take a $35 computer called the Raspberry Pi and you convert it to something called a Pi hole, it sets up DNS that operates in your own home network. And if there are malicious or nefarious redirections to trash on the internet, the Raspberry Pi will stuff those problematic redirections into its Pi hole, hence the name Pi hole, and just delete them. So that prevents hackers from redirecting to malicious sites when people click links. This is a very helpful thing. So it improves security and performance, and it costs 35 bucks. So you buy a Raspberry Pi and you set it up as a Pi hole. If anyone is interested in doing this in their home and you'd like to consider doing this, in addition to some additional credit on some of your solutions, you can post enough credit where you don't have to take the final exam. Send me an email if you're interested in doing this. If you'd rather do something hands-on and be the rock star of your local network, right? I'm just saying, that's a cool way to earn additional credit. And if you do the additional credit portions of each solution from here to the end of the course, you can check out and do something else when the final exam is grinding everybody else. Just a thought. Send an email if you're interested.
Yeah, it sounds viable.
Yep. Well worth your time. Not everybody wants to spend 35 bucks, but it's the best $35 I've ever spent in my life, and I have Pi hole running in my home environment. Okay. So, public-private IP addresses. This is just a review, but remember that these exclusive address ranges are considered public. But there's a gap. We skip 127 because 127 is used for testing purposes for network devices. You can ping any 127 address and it loops back to your own interface. It's called a loopback address, 127.0.0.1. It is also affectionately known as home by network professionals. So you'll see t-shirts, nerdy little geek t-shirts that say, there's no place like 127.0.0.1. And if you're technology savvy, you know what that means. It's like, oh, that's from The Wizard of Oz, right? It's a movie called The Wizard of Oz. And the heroine is clicking her ruby slippers together and saying, there's no place like home. There's no place like home. That's the magic spell. Anyway, back to our task at hand. Class B addresses. These can host millions of clients. These can host hundreds of thousands or tens of thousands of clients. These can host hundreds of clients. So millions, thousands, hundreds of clients can be hosted if the public network address range begins with these numbers. This is used for something called multicasting. So if you determine that a public IP address uses a business address of this, what class of IP address does it belong to? You look at this chart. Look at the first octet. That's what you're looking at. It's 131. So what is 131 up here? Which class of network is it? Come on. It's not a trick. 131 falls where?
B.
B. It falls between 128 and 191. Correct. That is correct. Now, official private address ranges by class. Okay. If it's the 10 range, that's excluded from this upper 1 to 126. If you hit 10, that's a private network. It's not public. Up here, if it's 172, it's excluded from the 128 to 191. So the 172 network is set aside as a private internal address. I want you to notice how many different addresses each can host. These private address ranges can host 16 million, 1 million, and 65,000. Okay. So if you determine that a private internal non-routable IP address, let's repeat that. If it's this, it's private, it's internal, and it's non-routable. That means that this network packet cannot be passed out to the public internet. Let's repeat that. There are some very confused network professionals that work in the Virgin Islands and elsewhere that think that it's okay to use public IP addresses in your private internal network, and they're full of it. Their eyes should be brown if they have a different eye color because they're so full of it. The reason that we have non-routable IP address ranges is so that if you're in a private environment and you have packets, you don't want a hacker to grab that packet and just reroute it out to the public network where somebody can collect it and read it and get into your Kool-Aid. If it's 172, it means it's non-routable. That means that when it hits the routers out on the public network, those are designed by intention to delete them and trash it. So you never want to have a private network, a local network that is public, ever. Yes, and I'm talking to some people who are Cisco certified and still argue the point. Shame on you. Okay, just saying. All right, how many potential clients can use the LAN? Okay, you see the chart up here. That's what we answer. Now, if you have a Class C network that uses a 24-bit block, it can host 256 addresses, and that is not shown here. You have a lot of private internal address ranges that start with 192.168, and they have a /24 or a 24-bit. They have an 8-bit block, the way this is stated here. They have a larger subnet mask. They have more ones. It's a /24. It means they can accommodate up to 256 connected devices. That is a point of confusion. Another point of confusion happens when we get to this special range, 169.254. This is another private designated range that's designed for automatic private IP addressing. That's literally what APIPA stands for, automatic private IP addressing. It means when you connect a device to a network, if there is no DHCP server present and there's no service on the link layer, if there's no ARP and DHCP run, well, there's ARP, but there's no DHCP. If there's no DHCP that's saddled on top of the ARP so that something can get an IP address, devices automatically assign one to themselves, a random address in a 65,000 range address range. And if it's random, it's pretty likely that it's not going to create a collision, right? Because they all do it randomly and they generate a random address in that 169.254. And that means that these addresses can talk on the local network until a DHCP service is available. Whenever you see 169.254, it always means, uh-oh, something happened with our DHCP service. It's not running on the wireless router. There's a problem there. Or you know, maybe I don't have a server. Okay. We just talked about 127. Any questions so far? Does this look familiar?
Like the mask, the subnet mask.
The stuff about the subnet mask?
Yeah, from first module.
Good. This is where we'll stop. We're finished with our review of that material. We'll pick up the rest on Monday. I wish you all good luck on your first attempt of the module 2 assessment. If you run into problems with your network solution for module 2 over the weekend, feel free to send me an email or text me on my cell phone. Have a great weekend.
All right, you too, Mr. Gonzalez.
Yeah, send me that email.
All right, I got you. Yes, sir.
Bye-bye for now.